The properties of the definite integral are fairly similar to the derivative properties in that if we have a constant, the constant didn't affect differentiation. That constant k here doesn't affect integration, so we can just put it on the outside. If we have different function parts, f and g added together, well, before we could differentiate them independently, well, here the same thing, we can integrate them independently of each other. Number 3 looks a little bit complicated, but it's fairly straightforward. If we integrate, we have this integral a to b, so I've drawn this underneath here. We've got the integral a to b. Well, if we split this up and integrate from a to c, and then stop, and then we start at c, if we start at c and integrate all the way to b, well, that essentially, if we think about the area, well, those two areas are going to be the same. So when we add those two integrals together, those two integrals are going to be equivalent, okay, as long as c is somewhere in between a and b. So that picture here, this picture here is explaining that number 3. For number 4, it says here that if I integrate from a to b, it's going to be the opposite of integrating from b to a. So what does that mean? Well, if I have some area of a curve and I integrate left to right, okay, integrating left to right this way, my area above the curve is positive. However, if I integrate backwards, now this is important because this shows up later on. If I integrate backwards, that area or displacement is going to be opposite or negative. And we can kind of maybe think of this in terms of our velocity graph. Imagine having a velocity and going right to left. If we have a positive velocity, our area, the displacement is positive, so that we would consider this area in here to be positive, a positive displacement. However, if we went backwards in time, we started at time B and ended up at time A, well, in that same scenario, we would have to think of where did we start from, or essentially we're going backwards. So we would have negative displacement going right to left. Okay, so if we go left to right, we have positive displacement. From right to left, we have negative displacement. So here I've given a link to Desmos and calculate area under the curve of y equals x squared. Make sure you go just kind of play around with that so you get an idea of how the fundamental theorem of calculus works.